Hey, welcome everybody. So today I'm going to talk to you a little bit about math of chemistry. The idea behind math of chemistry is dealing with things like masses, volumes, but also worrying about number of particles. So how do we relate the two? We can't see particles, so we need a measure of those number of particles in the lab. And so we're going to try and look at things like molecules, atoms, and we're going to try and do that by using things in the lab like mass, volume. So, let me give you an idea of an example of what this would be like. Imagine I said to you, look, 5,000 dozen, that's a lot. 5,000 dozen, that's 60,000 identical marbles. I want you to, count them out. And once you count them out, I want you to, tell me how much they weigh total. So, it would be difficult to do this. We would have to count each one, write down the mass, add it to the next one. That would take us a really long time. Now we could do that. With marbles, it's possible. Marbles are macroscopic. We could put them on the scale, but we would be here all year. We need a way where we can sort of extrapolate how much the mass of a certain number of them weigh. And, figure it out, to how much the total would weigh. Given the fact that they're identical, we can make that leap. So, if each of these marbles, are 25 grams, I can take this and I can say, all right, well, 25 grams of these, that's per one marble. So I have that 25 grams per marble. If I times that by 12 marbles, for every 1 dozen marbles, and then I times that by 5,000 dozen. What this will allow me is this will allow me to find the mass of those marbles. So if I go ahead and I do that, I'm just going to take my phone and I'm going to actually calculate it. So we would have 25 times 12 times 5,000. And so that would give me a total of 1.5 million, 1.5 times 10 to the 6 grams. So now instead of me, having to figure out, okay, well, I want to measure out 5,000 dozen marbles, that's 60,000 marbles. I don't have to do that anymore. Now what I can do is I can just say, give me 1.5 million, or this would be about 1,500 kilograms. Weigh out 1,500 kilograms of marbles, and I'll know that that's 5,000 dozen. So I know that if I have 1,500 kilograms of marbles, which isn't a crazy amount, 1,500 kilograms of marbles, this kilograms of marbles will be equal to 5,000 dozen. This is now a known entity for marbles. I'm doing the same thing when I work with molecules. Scientists know, for example, that 18 grams of water is equal to this many water molecules, 6.02 times 10 to the 23rd. And they call this a mole. And so just like we were able to build our equality between mass of marbles and the number of them, we now know for water that a certain mass of water is equal to a certain number of them. And it's a known quantity. It's called a mole. The thing is, each substance that we look at has a different mass that equals that many number of particles. And that's what we're going to get into. That's our first concept that you need to know about, and it's called the mole. So again, this quantity that we have for water, it's a set quantity. And it's the same as other set quantities as equations that you've used when you've done factor label. We've set 1 dozen equal to 12. We've set 16 ounces equal to a pound. We've set 1 year 365 days, and so on. And the idea is that we have these quantities. Well, we also have a quantity that is equal to a mole. And 1 mole of anything is equal to 6.02 times 10 to the 23rd. Now, this also relates to mass, as you saw, and we'll get into that as well, but this is really the crux of what a mole is equal to. And it's a factor conversion that you need to memorize. You need to know this equality. So look, when I look at, and ask, well, what is a mole? A mole, as I just showed you, but I'll define it here, it is equal to a certain number of any substance. And so the idea is, like if I had 1 mole of water, like we saw, we would have 6.02 times 10 to the 23rd of those water molecules. If I had gold, if I had 1 mole of gold, it would be equal to 6.02 times 10 to the 23rd of gold. Now, like I said in the first slide, the idea is to try and relate these moles, these molecules here. So this would be molecules. This would be atoms. The idea is to try and relate molecules and atoms to quantities that we can actually measure in the lab. Because in the lab, I can't take out a scale and it can't measure atoms. But I can measure volume and I can measure mass. I can do 1 and 3. Those are measurable quantities that I can use and that I will use. So when I look at this and I say, all right, well, how do I go about doing this? So volume of a gas. So there's a special condition that we'll always mention, and it is called STP, standard temperature and pressure. So if you picture yourself on a cold, sunny day at Tappan Beach, that is STP pretty much. It's 0 degrees Celsius, so freezing of water, and 1 atmosphere, which is a nice sunny day. So at STP, 1 mole of any gas at STP is equal to this quantity, 22.4 liters. So that's right. There is another conversion factor. We talked about a mole being equal to a certain number at the top of the screen here. We also have moles of a gas equal to a certain volume. And it's easy to measure volume. All you need is a device that has graduations on it that you can fill with gas, and we'll actually do some gas collection in the lab, and you'll see how that works. Now, as I mentioned before, for number 2, that 1 mole of any substance is equal to 6.02 times 10 to the 23rd, and I'm going to put the word particles. Because you could have any kind of particle being 1 mole. I could have a mole of electrons, I could have a mole of atoms, I could have a mole of molecules, I could have a mole of ions. You name it, I can have a mole of it. I could even have a mole of people, but nobody wants a mole of people. You tell me why. Okay, and then the last one is gram formula mass. Gram formula mass is the amount of grams equal to 1 mole. Now that doesn't really help you. How do I actually get a number here for this? Well, if we look at something like water again, we use the periodic table. If you look at your periodic table, the mass number of hydrogen, or the atomic mass of hydrogen, is 1. And there's 2 of them. And the mass of oxygen is 16, and there's 1 of them. So the mass of water is 18 grams per mole. Now, depending on, what problems you're looking at, or, what test you're taking, they want to know it to the hundredths place or the thousandths place. If you look on the periodic table, you'll see that. I personally just round to the whole number, and that's what I expect you to do. Now, gram formula mass, I define it here again, and I also sort of derive it. The idea that if you have a mole of something, it's equal to 6.02 times 10 to the 23rd. And if you have the gram formula mass of something, it's 1 mole, you can sort of combine them together. And 6.02 times 10 to the 23rd of any substance equal to its gram formula mass. So again, the gram formula mass, it is the mass of 1 mole of a substance So how do I find this gram formula mass? Well, I did the water example for you. Let's try something like calcium phosphate. So now I go and I look at my periodic table. Calcium's 40 grams per mole times 3 plus phosphorus is 31 times 2 plus oxygen is 16 grams times 8. And then we can get our total. Our units for this are going to be grams per mole. So go ahead, do some practice with this. Let's try something like C2H6, K2CO3, Na2SO4, PbC2H3O2. Find the gram formula mass of these four. All right, one last thing I want to talk to you about before I stop this video is our mole conversions. So you can convert from grams to moles. Let's say that you had 80 grams of water, and I want to convert it to moles. Well, I know that, for example, there's 1 mole for every 18 grams of water. I'm doing factor label. My answer would be 80 over 18, and that would be in moles. Grams would cross out. I could also go the other way. I could say, well, I have 6 moles of NaOH. Well, the gram formula mass for NaOH is 40. So times 40 grams for every 1 mole. And that would give me 240 grams of NaOH. I could do liters. Liters would require that 22.4 number. So I could have something like 80 liters of oxygen. Well, times 1 mole for every 22.4 liters. That would give me 80 over 22.4. And that would be in moles. I could do molecules to moles. So I could have, like, let's say, 9.1 times 10 to the 23rd molecules of water. And I could change this to moles, times 1 mole for every 6.02 times 10 to the 23rd molecules. Give me about 1.5 moles of water. So these are our factor label conversion factors. We have 1 mole over the gram formula mass, or gram formula mass over 1 mole. Notice the gram formula mass can change, and it will change. We could also have where you have liters. So we have 1 mole over 22.4 liters. You could also have where you're doing moles to molecules. So you could have moles over molecules. Just like with any other conversion factor, you can flip those factors around. So I could do 22.4 over 1, or 6.02 times 10 to the 23rd over 1. I just have to know where I'm going. And then I could do these down here where I have multiple conversions. So I could have something like, let's say 72 grams of water, vapor, let's say. And I could ask you how many liters. Well, I can't go directly from grams to liters. There's no conversion factor to do that. So I need to do 2 conversions. 72 grams of H2O times 1 mole over 18 grams. That's the gram formula mass. Then I can change it from moles to liters. I could times it by 22.4 liters over 1 mole. So if I do this, I get what? 4. So I get 4 moles times 22.4. So that's what, like 96 or something? 4 times that, 98. Yeah, I think it's like 96 liters. You can work that out. Tell me that I'm wrong. So as you can see, I can do all types of conversions here, depending on what I'm given. Why don't you try 1 molecules to grams? What if I gave you 1.2 times 10 to the 24 molecules of CO2? And I ask you how many grams that is. Let's see if you can do that one for me. So this is what we're really going to delve in tomorrow. This is what we're going to practice. This is what we're going to focus on. All right. Thanks for watching.